You are welcome to this physics class, and today I'm going to be taking you on components of circuits. My name is Nuruddin Busari. Learn your objectives. By the end of this lesson, you will be able to list the components of circuits. You will also be able to describe each component of the circuit. You will understand the relationship between the components of circuits, and you will be able to solve problems related to circuits. Introduction. Circuits make computers, digital cameras and video games possible, and even our mobile phones. It is circuits that make it possible. Circuits are driving an unprecedented rate of change in how we live. There are three main components of a circuit, and they are electrochemical cells, electromotive force or EMF, and internal resistance. Now that we know the three main components of a circuit, let's explain each of them one after the other. Electrochemical cell. Electrochemical cell is a device that generates electrical energy from chemical reactions. It also uses electrical energy to cause chemical reactions. And as you can see from the diagram on the screen, we have two main types of electrochemical cell. They are galvanic cell and electrolytic cell. Galvanic cell is used to generate electrical energy from chemical reaction, while electrolytic cell is used to cause chemical reactions by electrical energy. Now, this reaction can be represented with equation as shown. When zinc and copper are combined, they produce zinc, insoluble and solid copper, and electricity is generated in the process. Also, when sodium ion and chlorine ion are combined with the use of electricity, they cause chemical reaction of sodium in liquid form and chlorine gas. Electromotive force. Electromotive force is pressure developed or an electric intensity from an electrical energy or a source. It is measured in coulombs of charge. Electromotive force E can be represented mathematically as I into brackets capital R plus small r, where I is the current in amperes and capital R is the resistance of load in the circuit in ohms, and small r is the internal resistance in ohms. Internal resistance. When there is current present in the device or in the electrical circuit and there is a voltage drop in the source voltage or in the source battery, that voltage drop in the source voltage or the source battery is called internal resistance, and it is caused due to electrolytic material in batteries or other voltage sources. From the previous equation, internal resistance small r can be represented mathematically as E minus V over I, where E is the electromotive force of the device and V is the potential difference between the device, and I is the current in the device. Now that we know we have little, we can describe each of the components of a circuit. Let's take some exercise. Exercise 1. A given battery has a 12-volt electromotive force and an internal resistance of 0.1 ohm. Calculate its terminal voltage when connected to a 10 ohm load. Solution. We are to calculate terminal voltage and we are not given current, which means we need to find current first. From the previous equation given, I can be expressed as E, which is electromotive force, divided by R plus small r. And our electromotive force as given in the question is 12 volts, divided by external resistor is 10 ohm, internal resistor is 0.1 ohm. 10 plus 0.1 make 10.1. That is 12 divided by 10.1. And that gives us 1.188 ampere. Now that we know the value of current, we can use that to determine the terminal voltage. And terminal voltage is equal to E minus IR. Our E, which is electromotive force, is 12 volts minus the current multiplied by internal resistance 0.1, and that gives us 11.90 volts. The second exercise. A given battery has 12 volts electromotive force and an internal resistance of 0.1 ohm. What is the terminal voltage when connected to a 0.5 ohm load? Solution. Current I is equal, just like the previous exercise, we need to find the current first. Current I is now equal to E over R plus R. That is 12 volts over 0.5 plus 0.1, which is 0.6. 12 divided by 0.6 is 20 ampere. Now using the value of current to find the voltage, terminal voltage. Terminal voltage is E minus IR. And that is 12 volts minus 20 multiplied by 0.5. That is 12 minus 10, which is 2 volts. Now, in this lesson, we have been able to learn that cells, electromotive force, internal resistance are the components which complete the circuit and help the flow of electricity within the circuit. We have also been able to learn that cells, EMF and internal resistance are interrelated to one another. And batteries, that is cells. When we are referring to cells, we mean batteries. Cells poses internal resistance and potential difference. Circuits are the pieces behind the electronic devices we use. Assignment. The terminal voltage of a cell in an open circuit condition is A, less than its electromotive force, B, more than its electromotive force, C, equal to its electromotive force. Depends on its internal resistance. Second question. What is the potential difference across the voltage terminal of a cell with the electromotive force for the open circuit? A, terminal voltage is less than the EMF. B, terminal voltage is greater than the EMF. C, terminal voltage is equal to 0. D, terminal voltage is equal to EMF. Send your answers to gmosmith@edufirst.ng.